Assalamualaikum and hi. My name is Muhammad Nizamuddin bin Muhammad JAPRI. I am from Uitm Shah. I will present about my final year project 1 on entitled of the effect of infill parameter on mechanical and physical properties of 3D printed mold for craniofacial reconstruction. My supervisor is Dr. ABDUL MANAF and my co-supervisor is Puan NORAZURA MOHAMMAD. For the content of this video, I divide into 5 subtopics which are background, problem statement, literature review, methodology, and preliminary result. Let's go to the project summary. The study mainly focused on the effect of varying the infill parameter on the mechanical and physical properties of 3D print for craniofacial reconstruction. It should be noted that 3D printing is an innovation in manufacturing that permits the fabrication of complex models easier than the traditional manufacturing process. 3D printing also gives a lot of advantage, especially in terms of cost. In this study, a 3D print mold is suggested for implementation in craniofacial reconstruction. However, the mechanical and physical properties of the 3D print mold need to be accessed to warrant its function. For introduction, craniofacial is a medical terminology that refers to the facial bone. Craniofacial defects occur due to abnormal growth of the anatomical structure or due to the disease and trauma. Meanwhile, cranioplasty is a routine treatment used to correct cranial vault abnormalities. Additive manufacturing can be utilized for the creation of patient-specific synthetic implant. Some material that can be used in cranioplasty such as autologous bone graft, titanium mesh, and polymethyl methacrylate (PMMA). Injection molding can be used to produce cranioplastic plate from PMMA because PMMA produce high-quality plastic parts. 3D printing is an alternative way to fabricate the mold for application of PMMA since it reduces the time consumption on creating the bone substitute for cranioplasty. 3D printing shows great potential in medical treatment such as implant. However, the mechanical and physical properties of 3D print mold should be considered to produce a quality implant. For problem statement, craniofacial reconstruction is a challenging surgical procedure to improve the aesthetic and functional condition of the patient. However, cranioplasty using metallic material such as titanium is relatively expensive as it requires a customized titanium shape based on the skull of the patient. Additive manufacturing of 3D print mold could help in reducing the cost of the reconstruction procedure. The most recommended material is polyitic acid (PLA) since it is affordable and easy to be processed. However, the characteristic of the PLA-based 3D print mold need to be understood to implementation the process. There are 3 objectives, which are to assess the effect of different infill density and pattern on the mechanical and physical properties of 3D printed PLA. Second, to design a 3D print mold for craniofacial reconstruction with selected infill density and pattern based on objective number 1. Third, to determine the mechanical and physical properties of the 3D printed mold. Scope and limitation. This study focused on the response towards mechanical and physical properties using a variant of infill density. This study, the number of samples is 9 for tensile test, 9 for compressive test, while the variable is different infill density and different infill pattern. The type of analysis to observe the surface roughness, tensile strength, yield strength, elasticity modulus, and compressive strength. The limitation of the sample size made the experiment have a limited result. The test has been conducted separately since there are not enough machines in UITM, make it hard to complete the study just in time. Okay, let's jump to the next subtopic. For the literature review, first, the infill density. A 3D object can be created or made via additive manufacturing, which involves layer-by-layer construction starting with a CAD model. It should be mentioned that FDM 3D prints has different setting parameter value including infill density, nozzle temperature, bed temperature, and layer thickness. The term infill density refers to how much filament is printed inside of the object, and it is directly affect the print strength, weight, and printing speed. Process variables are crucial in regulating the physical behavior of the product, including part strength, surface quality, and accuracy. The criteria regulate the internal structure, build time, size, and form. With the different density of the product, it will give a different characteristic. The material, tensile strength, and compressive strength both rise with an increase in infill density. By reducing the infill density, the component strength result of the air gap, it will decrease the strength of the material. Facial reconstruction, the operation known as cranioplasty, which involves inserting an item to repair a defect in the skull vault. The planning, carrying out, and rebuilding of head and necks need a strictly procedure to guarantee the best patient quality of life. Repairing cranial defect has involved the use of several materials. The ideal material for cranioplasty would be affordable, malleable, and resistant to biomedical process (MA). The process to create the final products need to follow the state characteristic with low time consumption. Okay, next, for mechanical and physical properties. A study of the effect of part build orientation of fatigue behavior of FDM process using PLA material has been done, and it was shown that the specimen crate with a 45 print orientation has the highest fatigue life in comparison to those built in X and Y direction under cycling loading. Meanwhile, for breakage, high infill density will reduce the time of break between consequences layer. Let's go to the next subtopic, which is methodology. Methodology is a method on how I am going through on completing the study. First, designing phase. The dumbbell shape and cylindrical specimen has been designed based on ASTM D638 Type 1 and ASTM D695 as a sample specimen using computer-aided design software, which is CATIA. Next, save the file to standard translation language (STU) file. Next step, add the slicing phase. The slicing phase is the phase translating the 3D CAD model to the machine language that the printer can understand. Ultimaker Cura will be used for the purpose. Okay, go to the next step, printing phase. The 3D printing creality and the tree has been set up and polyitic acid PLA has been set as a material into the printer. Next, the STL file that has been saved is opened by Ultimaker Cura application. At the application, the parameter of infill and pattern has been changed accordingly to the parameter sample and G-code has been created and sliced. Then, the G-code has been transferred to 3D print and the specimen start to be printed. The next step, testing specimen. To assess the mechanical for different infill, several testing need to be conducted such as tensile test and compressive test using Universal Testing Machine (UTM). Next, the surface roughness of 3D prints has been observed to identify the effect of infill parameter on terms of physical characteristics. Next, model design. A 3D print mold will be designed based on actual patient skull defect using a computer-aided design (CAD) software. Next, slicing mold. The design mold will be sliced and printed using the selected infill parameter as evaluated in objective number 1. The step during virtual skull reconstruction process will be recorded along with the material consumption, printing time, and cost estimation in order to be transferred to the future actual clinical setting. Next, go to the printing mold. Print is using the excellent characteristic of infill parameter that been obtained before using Crealinity and the 3D printing. Next, testing mold. The mechanical and physical properties of the 3D print mold will be determined using the Universal Testing Machine and dimensional metrology and surface roughness measurement device. Last, data analysis. The obtained data will be statically analyzed using the statistical analysis software. The significant value will be set at p less than 0.05. Okay, let's jump to the last subtopic, which is result. For FYP1, the study only conduct with different density which are 16, 18 and 100% with same pattern, honeycomb. The other different density and pattern will be planned and conduct in FYP2. Figure show the stress strain curve of 3D print PLA which was prepared at different density using honeycomb pattern. By referring to the graph, it's shown that specimen prints at 100% density H3 having highest value of stress, 31.07 megapascal compared to the others. This means H3 can withstand the maximum stress compared to other while being stretched before fracture. Figures show that H3 with 100% density having greater stress than that can be resist compared to others. From table, it shows the elastic modulus for honeycomb with 100% having a greatest elastic modulus maximum stress that can resist. The highest elastic modulus meaning the highest stiffer of the material. It means it's not easy to be bent. By conclusion, the honeycomb with 100% density having good mechanical properties, and it also has been proved from other research paper. Thank you.